Okay, my friends, this is getting fabulous. It's really getting good now. I'm seeing everybody is starting to question what we have been dictated to believe. Now, I just got off of the Veritasium channel, and then I got off of Kane's channel, which everybody's talking about things that it's just all theoretical nonsense, really. That it's once a person gets in control of the narrative of the science dogma, you're forced to repeat that, or you're told to go away. And that's what happened to me. That's what happens to basically everybody that's been in the same position I have. And I believe Robert Seffer here is also in that position, and basically everybody now that's come up with the facts. And they're going to be explaining, and I am going to be explaining, and it's finally happened. It's been years and years and years in the coming. Now it can't be denied anymore, and the case she is about to close. Now, this is Robert Seffer. He's talking about Jules Verne, who was really talking about reality. He had to make it into a story that made it sound like fantasy. And every single thing up till today is the same story. If you come out with the reality, you get put in a corner you're never heard from again, trust me.
A predatory stance against alternative thought in mainstream academia, uncensored speech in mainstream media, and free thought in general when it comes to anthropology, which by any academic standard is still relegated to theory and politically biased hypothesis and not scientific fact.
Now, he's talking about anthropology. Yes, absolutely, 100%, but also everything else. Anything that's in the theoretical realm is dictated now, such as a standard model, which I have proven, literally myself, that it is wrong. And nobody will stand up. They've taken a predatory stance against reality. That's our education system now. Okay, here's Dr. Paul Sutter, very top-end physicist, talking about the new particle, this W boson, which I will show you. I have discovered it long ago. Now listen to what he has to say. Fraser Cain's asking him, what is this W boson? What does it mean to us? And can you explain about it? And here's what he has to say.
Each one of these four forces of nature has a set of carrier particles that carry or mediate this force from place to place. So for electromagnetism, we have the photon, which everybody knows and loves. For gravity, we're not going to talk about gravity.
Right. Yeah, the reason they don't talk about it because the standard model doesn't cover any of that. And there's nothing about dark matter. There's nothing about gravity. All these things we know exist, but they can't predict them because the standard model is totally, completely wrong. Everything is made of dipoles. And this is now the new standard model. Done. That's it right there. None of this nonsense with all these different particles. That's the only two particles that exist, a muon and an electron neutrino. You put them together, the black and white ball, and you have what we would always consider to be an electron that does a sparking and static and lightning. Then you took two of these together back to back, you have a photon, which we all know and love. Nobody knows what a photon is. Even Fermilab, they have no idea. They don't know whether it's a particle or a wave or what it does. I show the actual particles, and I show that everything is made of dipoles. That was my theory 50 years ago. It is now proven true. And I want to be able to speak about it because I think we can get free energy. Okay, these are the particles that Don Lincoln was talking about. And there's the fixed particle, it never changes, and then there's the point particle, which can come and go. And this one I have found has all the mass. This one has no mass to speak of. This burns, this doesn't burn. And here they are in our experiments. Remember, the black ball right there is that black ball right there. And it never changes. And I know that it doesn't. And it is too big to fit through the Venturis because we were able to separate these particles. This is the point particle. I never thought you could separate them. I thought they were glued together like a little bar magnet, just like this. And in their normal condition, they are. They're exactly like this. Exactly like that. And what happens is the bottom one going forward, if it was going in this direction, this one is bumping into these little particles. I don't know if you can see those or not. but I have other shots to show them extremely well. But these are the particles. Now, this obviously you see is expanded and growing in charge, and this one is depleting because it's going forward. This is pushing, these are shoving, it's push to shove. Now, these are light particles. These are photons. Right? This is a photon. This is not, and these are exactly what Fermilab sees in their smallest particles. But they started with huge chunks, which we always were told a proton was one big mass of positive. It's not. It is 1,839 dipoles, just like this. This is two dipoles together, makes a photon. Photons bounce off of you, and you see however hard it is and however impact, that makes up the color you see. Sometimes it bounces back hard, you get in blue and really bright, and sometimes it just bounces back easy and it's just dim and red. That's the nature of the spin. And it's all related to the spin. And I could show you that too, because I could show you the red versus the green. They're totally different. Now, so what do we have so far? We know the point particles and the fixed particle. We see them here. We see this is a photon. Now, where did that photon come from? Well, it came out of a red laser, and it was in here. And because it has a field around, a magnetic field, this is its field. As it comes through the air this way, everybody in front of it, all these particles that are in the gases in the air, have to get out of the way. So they begin to glow. And it looks to me like it's accelerating. People say, oh, no, that's not acceleration. I don't know how you can miss that, but who cares? I can see the energy value is exponentially increased here, exponentially. They claim about 207 times. That's, if you can divide, which we did, the black from the white, which was this black from this white, the muon from the electron neutrino, we divided them. And here it is right there. There's the black divided from the electron shower. This is not from me. This is from CERN or Fermilab, both basically. We're looking for a muon neutrino. We're looking for an electron neutrino. And there they are. Muon neutrino is the black, electron neutrino is the white. So we've found them. Now, then they turn into showers when they hit other medium, which is called the Cherenkov radiation reaction. And here it is right here. Now, what did they hit? Normally they hit like heavy water or something, so it really boom, sort of stops them. Well, this is just like heavy water, only all we're letting through is a tiny little squirt, which is the white. The black can't get through, it's too big. It's a fixed particle, a fixed, solid, non-changing, fixed particle. This one can squirt through because it has the ability to crush down and squirt through the venturi. So we created the muon, sterile muon, and we created electron showers, which means that we created a division of those two particles, which were together. They here now are divided, which is called fission. Fission just means you split something apart. You cut it apart. We removed the black from the white. As you can see, there's zero blackness in here, not even a taste. However, these white ones desperately want to be reattached to the black. And boom, right here they come back together. And I mean they slam back together. And when they do, the energetic value of that concussive event radiates around identical to a nuclear explosion because it is a subatomic nuclear explosion you're seeing right here. When you split them and they come back together, that is a nuclear fission and fusion. But we're on a subatomic level now. When you go into the atomic level, so let me just explain to you very easily, very, very easily. When you have a gigantic nuclear bomb, you got all kinds of stuff, and they crush it together so hard, everything goes. Well, the first things that are going to go is the white particles, because they're coating everything. They take off. Then the black ones go behind it. That's why a house will burn, and then a second later, it explodes. The burn is the white. The burn, this has no impact value whatsoever. Absolutely, as far as I'm concerned, it has no push. It's a burner. The black ones they are pushers. They just push everything. And that's why houses explode. Now, what we've done here is shown the particle dividing here, fission, squirting through the venturi, single slit. This is not related to overlapping waves of a double slit. It's related to the push away and the shove away between each line of particles. This is a repulsion pattern. These don't want you to get away from me. All right, you stay away from me, I'll stay away from you. I'll stay away from you. And zip, they set up a line of interference. You know, they call it interference patterns. Call it whatever you want. It's a repulsion of electrical fields. I got my field, and that's why you see these little, and if you look at a galaxy, the swirl of a galaxy, you'll see the exact same thing, only it's because it's swirling. And as it swirls, one pushes against the other swirl. You end up with lines in between every one of the arms of the galaxies. It's just a push to shove. And you see this? There's all kinds of other particles here that are coming forward. You see them? This is the only one we can see because this is the only one at this point in time, way back here, that has enough energy to be shown. And why does it have enough energy? Because it's starting to be accelerated. That's why. These are not being accelerated because they are not in the line of the venturi. They're there. We just don't even know they're there. They're everywhere. They're everywhere. We just don't know it. This, when it exploded, pushed back so hard that we could see the leading tips of them because it's just a concussion going this way, not going this way. You understand? This is re-radiating out backwards. I have other shots that show way back here there's fields, like just enormous fields coming back, like a nuclear explosion. You wouldn't expect them being way back here, and they are. You'd expect them to be little ones like this, but no, they are just swarm of particles, of concussive event. I don't know if they're particles or not, but it's a wave of influence, magnetic influence. And you can see the brilliance of that. If you can't understand, that's an increase of energy, just gobs of extra energy. And all of the things that they're saying, I have shown, are actually factually true and demonstrated in these experiments. And this is exactly what Fermilab is talking about. We did it, and it's time to take a look at it, because I think we get free energy. I've been talking about this for years and years and years. We should have free energy right now. You should be driving your car for free. That laser is putting out that pulse. Let's say it takes 5 watts to run it. You saw the increase in energy over here. If we can harvest that energy before the white particles get back to the black, all we do is run the white particles through our conductors, which would be copper and so forth, and then they will push motors and motors and lights and pumps and all kinds of things, and then they get back to the other side. That's how electricity works. You get a potential, and then you get a resistance that says, no, you can't get through here unless you push me hard. And it says, I'm going to push you like hell because I got to get back to those black ones. And it says, well, if you push me, I'm going to spin. And he says, well, you better start spinning. Boom! And it goes through, and the motor takes off. And they take off like electric power is just, it's the best there is. And there's no expansion to the gases in our environment. It's totally free. It's made from the most inexpensive materials on the face of the earth, really semiconductor, just little metal, thin and very, very thin films, not even thick chunks or anything. And little lasers, cheap you can get. You know, you need some form of a battery to back it up a little bit, but mostly you're just going to run it as it runs. Because if you can get an extremely increased amount of energy here, you just drive with that. And you can have as many lasers as you want in a box, a very, very small box. I was showing some experiments. I don't know if I showed you. I probably didn't, but anyway, they're solar cells. And you put a laser into a solar cell, it'll put out, I was putting over 2 volts in one of these little tiny cells. I get the cell right here somewhere. Here's one over. This is the size I put over 2 volts from that little bit, from a laser. Watch this. I'm gonna turn the light off. Now, check this out. This is a blue laser, you see it? See that blue laser? Let me come down here. Alright, there's a blue laser. Now I'm going to put this little thing down. Look at that. Let me see if it makes it a big. I'm over here, now watch. Here's the laser. Now I'm going to put it right next to there. Watch that. Okay, this is Fermilab, and I agree 100%. It says if you magnify an extended particle, it will look bigger. A point-like particle will not change in size, but the more closely you look at it, the stronger the field surrounding it becomes. Well, let's take a look at these particles. This is Don Lincoln from Fermilab. Let me show you those particles. All right, watch this. They're going to start laughing again about the gravity. Now, I would like to have Fraser Cain, who is talking with Paul Sutter. I would like to be involved in this discussion and make my statements as well. Listen to what he has to say about particles. I'm showing you that there is only 2 particles that exist, the muon neutrino and the electron neutrino. Together they make what we would consider the smallest particle, which is the electron. And electrons added together make protons. Listen to this now.
Electromagnetism, we have the photon, which everybody knows and loves.
Nobody does.
For gravity, we're not going to talk about gravity. But strong nuclear, there are a set of 8 particles called gluons. And then for the weak nuclear force, there are a set of 3 particles. These are the W plus, the W minus, and the Z bosons. And they get these different designations because the 2 W bosons have the same mass, but one is positively charged and the other is negatively charged.
All right, I'm just going to leave it at this. He's saying there's all these particles. I say there's only the 2. Let me show you the particles, because they talk about them, but I show them. All right, I just did this one not too long ago, and this shows the house in that slow motion experiment. And they are going to set off the atomic bomb, and you'll just see the house burn, and nothing moves, and then all of a sudden it goes flying. The reason it burns is the first thing that was on the outside of the ball goes. And that's the burner part, which doesn't push anything. It's the white part. Then the black ball comes. The black ball is the carrier. It normally holds together and they just keep moving around all the time. Well, in a nuclear explosion, you can literally drive the white one away from the black one, and it precedes the black one. Then the black one comes, which is the banger. Now you watch here. House that they tested to see how it would do it. Now watch what happens. I'm going to run this. It's running about 50% of speed. Now watch. First thing will go off, you see a gigantic flash. Boom. You see that? That's the huge. I'm stopping it here and there. That's just nothing but a white flash. And that's all the white particles that were on the outside. Now, there's just enough of them that they can just look at. Burn, just burn. No, nobody's moving. It's just a burn. Burning, 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 burning. Look at it. It's just burning. Why? I thought an atomic bomb banged everything and knocked it around. No. I can tell you why, and I did. Because the only thing that's hitting right now is the white ones. These are the burners. Now, because they were on the outside, they left first. And now the black ones are going to come behind them, which is the carrier particle. Oh, it burns everything first. And then comes the heavy-duty stuff. All of the burnable stuff is gone. Now comes the heavy-duty stuff. And watch, bam, there it goes. And watch, now it's not burning anymore, it's just pushed. And that's the black particles following their white partners. And now it goes way out, and then watch it turn around and come back. See, it can turn around and come right back. And the reason it comes back is because there's a lot of that black particle is still back at the tarmac where the bomb went off from. All the white ones went, and then a lot of black ones went after them, but there's still a lot of black ones that don't have partners. They pull them back. That is called gravity. The black is the gravity. I just explained everything that they're missing. What I'd like you to do is email Fermi Lab and ask them. We do have questions. I can't get any answers, but I've certainly got questions.